and tell. A school deployment, when I'm talking about deployments, we're talking about putting these EXO laptops in schools, generally speaking in the developing world. I spend most of my time working on this in Rwanda. A typical school there will have about 200 laptops and about 1,000 students. In Rwanda, they focus on grades 4, 5, and 6. So they'll maybe have 1,000 students in grades 4, 5, and 6 that share 200 laptops, which raises a whole lot of stories of itself. Normally, you'll see a picture, but this is a school server. A normal school server is a new unit of computing style machine. So deployment really consists of a set of these laptops and a school server connected by a local area network by Wi-Fi. If you look on your web manager, you'll see red Dell. That's that school server. Here's an example. This is actually the Kigali Public Library. Kigali is the capital of Rwanda. The Kigali Public Library is literally the only public library in the country. And there's a pointer thing here, right? No. Anyway, the black box there is the school server, typical style NUC cat device. Right next to it is an external hard drive which is used to install the software and content on the school server. On the other side is a router, which in schools we typically use TP-Link or similar routers connected by Ethernet cable from one classroom to another. So typically each classroom will have, great, okay. Punch something or? Aha. Okay, so there's the school server. There's the content hard drive, and there's the router. And of course the students in the library are using the laptops. So this would be not a typical deployment since typical deployments are in schools, but that's the equipment. Okay, this is what you see if you connect to the school server. The purpose of the school server is that the laptops themselves have limited storage. In the context of this meeting, we're talking about really small change. The EXO 1 gigabyte. The other one's 4 gigabytes. So there isn't any much room there, and these schools are not connected to the internet, not even remotely connected. So the purpose of the school server then is to provide that content. We've taken down Creative Commons and similarly free open content from the internet. So you can take a look there. You can see Khan Academy, a really excellent program in math, PHET, which are simulations of science, OpenStreetMaps gives a global map, World Literature ebooks, these are Gutenberg books. There's some 40,000 uncopyrighted or post-copyrighted ebooks. Wikipedia, this is the full English Wikipedia with pictures and the whole bit, and so on. So lots of content, but here we have to get to toward the problem. If you open up the XO, this is your screen. This is Sugar. The goal of Sugar was to use icons and to make an interface that was extremely simple for children who are not fully literate, because in many of the developing countries they're trying to become literate in English or Spanish or French, but that's not their native language. So the material is being presented in a language that children are really not yet that familiar with. So each one of these items around here, I'll get the point on the button here, okay, is a different application program, but we call them activities. Important one right now, that's the browser. And of course, with the browsers, they connect to the school server. Now here's where iRODS comes in. This is the journal, and the journal is where all of the work done by the students using Sugar is stored. The file system is really not visible. That's where the file store is. It's actually a Python object. The files are being stored in an internal format, not in normal file format, and not in the normal file system in a sense. So each one of these lines, whoops, I picked the wrong one. Hang on, technology here. Okay, so each line up here represents a different activity that the learner has run. So here's turtle blocks, and the turtle makes a square, so you give it that title. The record activity operates the camera and the microphone in the laptop. And here was a image taken. Here's a Word document, and so on. This is a Paint program. And these files that the student may have created are stored in the journal. Now, you have limited to 1 gigabyte. So the problem is, during the year, they'll exhaust that storage. They get a message that says, your system is full. We give them no hint what to do about it. So what teachers do is they take their USB stick and reload the software, which has a very unhappy property that it erases everything the student has done up to that point, which makes the journal basically useless. So the school server, we have a terabyte, plenty of space, and we can connect to it. So here's what we're looking for as a solution. We want to archive the journal, not back it up, archive it on the school server. The difference being is right now we do have a backup program, but it only backs up content that's actually in the journal. So when it does an rsync, it deletes everything in the backup that isn't now in the journal. So if you lose something from the journal, you're dead. And a journal object really consists of 2 pieces: the data file itself and metadata, describing who did the file, when it was done, that kind of thing. And when I saw that, I said, iRODS, metadata and data, great, good match. So it's a natural. So the way this thing will work is when the user connects to the browser through the network, the browser will run a script, which I'm calling archive.py, which will basically look through all of the journal objects and find ones that are new since the last time they were saved, okay, and backs those items up to the school server, puts them up on the school server via iRODS, okay. Now, a key point here, let's see if I can get back. Wait a minute. Yeah. If you look over to the left, you'll see the star. That star is a button. If you click, it's filled with a color. And if you click it again, it's blank. When it's filled, that's keep. And when it's not filled, keep is false. It's just a binary amount. But that's important in this project because what we want to do is, let's see, basically we want it so that when the browser is going through all of the objects, if the user has clicked on that star, making it clear, that means they want to delete that object from their local store to free up some space. If they click it again, then the browser, when the script goes through, it will go up to the backup store on the school server and download that file. So this way, the user has ready control over how the space, very limited space, in their machine is being used. And if for some reason the laptop goes bad, or they need to put a different one, they can then download all of their journal from the school server onto their new machine, which they can't do now. Okay. Bernie, I didn't put that in the show and tells, but basically an external hard drive with a terabyte that has all of the content. The reason being the schools don't have internet, so you must install the school server locally. So by having a hard drive, I can use that to install multiple different school servers from school to school. And probably the only thing that will be useful to you, that could be useful to you, is the script that sets that up. And there it is. Here's the problem. When you set up iRODS, you do it from the internet. That's easy if you have the internet. Not so easy if you don't have the internet. So the school server is using CentOS 7, and this script has a list there of all of the RPMs necessary on CentOS to install iRODS. That took about a week by try dependency missing, find that RPM, bring it down until it finally worked, but it does. So there's some work went into that one. Okay, and this is, if you notice up here at the first thing, it is the SU-C to install the Postgres. And so these are the commands. You've seen these. These are the ones right out of the book. Okay. First thing this script will have to do is register the user to make them an iRODS user. Now the trick to this is we don't have users in the laptop. The user on every laptop is OLPC, the Unix user. So what I'm going to do is make OLPC the iRODS admin. Therefore, the I command on the laptop can make a user. And the easy way to do that is do it every time. If it succeeds, fine. If it doesn't succeed, just check and make sure that that's an existing user. If it's an existing user, go for it. Now, the user is identified by the laptop serial number, derived from one laptop per child, so therefore there's a one-to-one correspondence between laptops and children, so the serial number works. Not true, but that's the mechanism we have at the moment. So what we'll do with iRODS is create an iRODS user, a normal client user, with the serial number. And this will be put in the vault. Okay, so all the content on the school server is in a partition/library, so we have plenty of space. And so there's a user's directory there, which will be the vault. So now every time I create a user, they get added to the vault, and every time they upload something, it gets put in their folder, which is exactly what you want. Okay, so what the script is going to do after it's identified the user and everything, that's okay, is it's going to look at every item in the journal. There's a Python class that gives that interface. Okay, it's going to check the keep. If the keep, that is, that star is set, it'll check to see that the file is local. If there's not a local copy of the file, it'll download it. Okay, if keep is not set, it will check to see if there is a local copy of the file. If there is, it'll delete it. So this will take care of that storage management issue. Then it checks to see if this object is new, that is to say it was created after the last update. If it was created and if it's new, then it needs to upload the metadata and the data file. Now, rather than have separate metadata for each of the metadata items corresponding to the object, what I'm doing is creating a JSON string and gets uploaded as metadata. I can't remember what I called it, but essentially it's the metadata associated with that object. Now later it might be desirable to split some of those out to get search capabilities, but for right now we're just dealing with serial number. So I talked about that already. I think that might be the end. Okay, so I'm open for questions, and I suspect I went fast enough that there'll be some. Questions about sugar and OLPC are perfectly in order. Questions about iRODS, I'll do the best I can.
How many of these archives do you plan to have?
There'll be one per school server. Probably in Rwanda, if they get some funding to buy the servers, they'll be in the order of 1,000
Okay.
independent machines.
The reason I'm asking is that is it I don't know if maybe it's not feasible to have a common server across Rwanda rather than having it in.
It would if
Yeah.
we had internet, but we don't. So there's really no communications
I
between
agree,
the
I agree.
schools.
Yeah, I'm aware of that particular one. So are you also working with the e-granary people who are also?
I have spoken with them. Their mission's a little different than
I agree.
mine in the sense that they're collecting data, some of which is proprietary and not well segregated. So I have an e-granary system, and I hope someday to have time to go through and see if I can find creative content. The problem, of course, is copyright.
Yeah.
If I have the material, they say on the internet, oh, this is free, have at. But that doesn't give me distribution rights. So if I download it and put it on the school server, then I'm violating.
Yeah.
So it makes it really hard to find content that you can use.
Because the why I'm asking is also e-granary is also using iRODS to do some of its journaling capabilities.
Yeah.
Yeah. Okay. Thank you.
Are you using anything like compression or other policies within iRODS to help manage that data? So once the data is at rest, you could run compression
Right.
to save some space and whatnot.
Yes, we are, but the interesting thing is the reason we compress files is that upload works best on a file and not a directory. So we zip a lot of things.
Okay.
But I haven't done it from that point of view, and really haven't done it to compress storage so much because basically we have a lot. We roughly have about 500 gigabytes of real content, so we've got at least half the space available for this backup.
So you would have enough space for the entire education of the child, so they would have a record of all of their efforts.
That's exactly what we're
grades.
hoping, that this will give the ability for this journal to actually show their data over 2 or 3 years. Typically in Rwanda, it's a 3-year cycle that they'll have it. And then they can always back it up to a USB stick or something to put it on another machine.
And they could take it with themselves, take it
Yeah.
with them after
Yeah.
they're done? Yeah, very great, thank you.
Yeah, I was going to ask a question myself.
Yeah.
How often are these school servers visited by people that have been on the internet recently? Because
superb
you
question.
could potentially create an archive that spans these school servers, even if it's asynchronous and it's a high latency of
Excellent
like
question.
months and
There
years.
is no resident admin anywhere within 100 miles of any of these schools.
Sure.
So the model is you set it up before the start of a school year, you keep your fingers crossed that it will continue to work through the school year, and then the next year you update.
Yeah.
It's basically the way it works. And up to now, it's been completely static. We put the content from the internet on there, it's basically read-only. So we're really pretty safe.
Right.
We start to get into this where we're updating the content, and we like to do that a lot. We want to find ways for teachers and students to get their own content up on the school server. That's obviously going to make it a little more unstable and more needs for resident admins. But system admin skills are just very few and far between in these developing world countries. So.
Sure. There was one more, I think.
Somebody there.
Or maybe I asked the same question. Okay. Apologies.
And
right.
I'll try to leave this up, so if anyone wants to connect to Red Dell, you can take a more detailed look at what's on the school server.
And how would they do that right now? They would.
On your, network manager, you just connect to Red Dell, and then it's http://school server, and you'll get that front page that was there.
So Red Dell is a wireless network?
Red Dell is a school server.
It's an access point.
And so that, yeah, and so it has a built-in access point,
Got it.
which is Red Dell, yes. And that makes it great for development because I don't have to run around with a router. But HTTP school server, after you're connected to Red Dell, and each one of the tiles is a link, some link to another page of tiles, and other links directly to the content.
Very cool. Thank you.